In this episode, we will learn how to code heat diffusion equation using Python, and we will mainly employ the FTCS method that is called forward time center space method, that is already discussed in the previous episode. The link of that episode will be given in the description, and it will be discussed detailed. And the main equation is ui t plus 1 later time, that is lambda times ui minus 1t plus 1 minus twice of lambda uit plus lambda ui plus 1t. This is our the finite difference form of our diffusion equation, which is given here, k times d2u dx2 plus du dt, this thing, with the initial condition ux0t that we have to put fx for all points at about t equals to 0, that is fx, and u0 comma t is a and ul comma t is b, other end of the rod. That is the given problem. And here you know what is the lambda that we already discussed, that is k times delta t by delta x square, and for stability reason that will be discussed later episode, that is must be lesser equals to half. That should be taken into account while forming the explicit method. Okay, now try to code it. First we have to import all the necessary modules, import numpy as np, and then import for plotting library, import matplotlib.pyplot as plt. Now I just setting the parameters of the program. What are they? Basically the length of the rod, say 1 meter, that is length of the rod. And I am just dividing that is over some points, that is grid. The number of points, say for time being it is 9 points, number of grid points, number of, say I will change it later on, just first time just initiating it, number of grid points, and dx. What will be dx as we already discussed, which is L divided by the total grid points, that is n, capital N plus 1, because here if you see xi equals to I delta x, the grid is running from 0 to n, that means n plus 1 points. Okay, n is the number of points, so therefore the sum xi, that is total length, that is equals to n plus 1 points, that means L divided by n plus 1 points. And the grid in x, that is grid in x, and then you just print, you can print it for your checking purpose. Print, always take the print while doing the program for checking any error or all the parameters, that just you run it and check it intermittently. That is point 1. Fine, it will be changed according to problems and your necessity of accuracy and all that. Just you are starting with that value. And dt, say time is say 1e in scientific, 10 to the power say minus 4, 10 to the power minus 4, that is your time step. Okay, and say diffusion constant, that is taken, it is not given in the problem, but I am taking for as a say 0.25, that is your diffusion constant, diffusion constant. And now set the BC, boundary condition. Now set the boundary condition. What are they? Basically the boundary condition, the left boundary condition. Say I am starting with the left boundary condition, says TL, which I am setting says 0 value, and T of R, the right boundary, which is suppose 100. It is given. It will be given in the problem, but I am taking this as an example. And the middle points of the rod, say initialized with say 50, I'm just taking it is 50. Okay, these are all floating points. And now I calculate the lambda parameters. What is the lambda parameter here? The lambda parameter is capital. If you take the small l, then it will be a keyword for Python. You do not take that. I'm just making it capital L. Lambda parameter. What is that? Which is k multiplied by dt, whole thing divided by dx square. This is your lambda, and you always take the print of lambda. What is, if you should check, always it should be less than half, that is 0.5, always less than 0.5. That means you just check the grading. It will be discussed later on. This level, I'm just run it for if there is any error, that will be checked, and that is fine. That is 0.002, which is much less than much less than 0.5. That's okay, fine. It will be stable thing. Now I am creating a container for storing the values of u. Say u equals to an empty list, np dot empty, np.empty, which is say n plus 1 points and floating point, the character, that is float kind u. Okay, and now setting the u with the boundary conditions. The initial value of the u, say u of 0, the initial value, which is say left of the array, that is t underscore l is the left I'm setting, and other end of the boundary, which is n, say or you can set it as, I think, -1 also, other end, that is t underscore, I will check it definitely, always check, and the middle points, that is 1 to n, which is t underscore m. So whether that two values are initialized, you always check that. Print u, that will be, just check it. That is 1D array. Fine, that is 1D array. The first value is initialized with 0, TL is 0, and the last value is 100. This is initialized, and the middle values are 50. That is okay. That is absolutely fine. The middle values are 50. That means our whole scheme is perfect up to this point. Now I just for recursive print, I have just block this. I don't need. Now I'm starting the time t equals to 0, and there are some t final, t underscore, say as not underscore tf, that is a final time, that will be something, say 5. That will be something, say 5. Now I have to in the left hand, you know, this is your the main equation. This is your main equation uit. I'm just connecting the lambda in the common, that means ui minus 1 t, and lambda common, and ui plus 1 t, and minus of twice of uit, and another term is uit. I'm just writing it in that way. For a time loop, I'm running the while loop. I'm writing a while loop in order to carry out while t some lesser or equal to tf final time colon for I in range, some I is some index, or in range, I in range 1 to n, the intermediate points, 1 to capital N, which includes the intermediate points only. And you have to run this program ui, that's equals to u I plus 1, sorry, ui, just of u multiplied by I, u I t. The t is right time you are calculating. It is in the next t plus ith time instant. I am just here calculating the previous values, based on the previous values, multiplied by lambda star, and the three things: ui minus 1, ui plus 1, and twice of ui minus 1. That means ui plus 1, you just remember the central difference formula, then you can easily remember the formula, and ui minus 1 and minus 2 star ui. Fine. I hope it is correct. Absolutely, lambda times this thing, and this thing, and I hope so, and everything is quite correct up to this. I'm just run it for checking is there any error. For I in range, so therefore the error will be removed. Or it may be the other error may be there, but just there is a missing I in, that will be checked at this point. Fine. This is your this thing now, and my thing completed. Now you just if you plot plt dot plot q, say what happens to it. Okay, and there is a keyboard interrupt. There are many plots, so that's why it will be a complicated thing. Therefore, because there are so it is error because time is not it is infinite loop, so we should not, and now you increase the time, so that's why then it will never reach tf, so that's why it's infinite loop. Therefore t should increase by t plus dt, and dt I think is defined, dt is defined here, and you increase the dt and you plot, and just check it. It will be also a very cumbersome, because there are many time instant. It is very small and infinite number of there are huge number of plots, so we should not run. So that's why I am just making a time slice. I will not plot for every times. There will be some points that will be that particular point that will be plotted. So I am just taking a t array, say t snapshot. I will take a snapshot kind of thing. T snap, that is equals to in say 0.1 time, then 0.2 time. It's an array over on at which we will take the snapshot of the u. What will be the behavior of u, and say 0.1, 0.2, say 0.3, 0.5, and say 0.6. Say there is a bigger time, say 1. 0.1, 0.3, 0.5, 0.3, 0.5, and 1. These are the time at which we will take the plot. Therefore, if we want to take the plot of the at particular time instant, then I have to check if np dot I take the absolute difference of time. That means at a particular time instant, this time instant, what will be the value of this u, and t will be increased in this loop, and after some time, whenever the absolute value of t minus t snap at 0th instant, 0th means 0.1. I am starting the game from 0. I will say TF will be defined in such a way. Say T snap, it will run for up to this point. T snap up to say there are 5 elements, 0, 1, 2, 3, 4. Sorry, 4 elements, 5 elements up to 4 index. T snap 4 means that it will run up to 1 unit of time. That means 4. What is the value of this array in the 4th position? That is 1. That will run for 1 unit of time, maybe second, whatever. That is, if I'm just check condition, if np dot absolute, the right now the time, and you increase the time, say, because it is calculated later on. This part is the later time calculation. So I increase the time t plus delta t. This is calculated basically at t plus delta t. T is this value and t plus delta t is this value. So I increase the time. If t minus this t, updated t, minus t snap means snap 0 means this element 0.1 second, that will be 0.1 second. If this happens, if this condition met, then you plot this thing. You plot u. Fine, and you just make a marker, say this, and label, and also you label at which time it is given, that is label equals to some time will be printed, that is equals to passed by this at the time that this time will be printed, that means str string. I hope you understand. This label means t, the time will be printed dynamically from here. This is for a single time instant. I just check it, then I will add much more timing, and I am just one thing, that is I am writing here for plt.legend, that will help to distinguish which one for what. plt.legend, their location is equals to best. I hope it is perfect, and I run it. If there is an infinite loop, then you have to check it, and there is a UI plus 1 if just running it, still running it. Why? Making something is wrong in this program. Okay. Oh, sorry. If the condition not met, sorry. This should be lesser or equals to something. Otherwise, you cannot. That's the reason you just check. Say e to the power minus 6. If absolute value is something less than, I miss it. Less than, then it will be plotting. If that condition not met, yes, yeah. If after the, then that will be run for this thing, and this is your the first curve, that is t means 1 second, 0.1, that is actually this is less than the difference. If you make it much more precise, for this is your introductory program, okay, and this is the curve, if you make it 0 time snap, just that will not be, basically there is nothing, because that will not be initiated at this, because it's already been updated. Oh, therefore this is your 0.1, say this is your after 0.1 second. Say I make it last point, that is 0 1 2 3 4, that means 4. This sort of curve will be there. If I make it the time say 2 second, if I make it the time 2 second, this is almost a straight line, because diffusion equation becomes this is a diffusion equation. Whenever you reach the steady state, that means du dt is 0, then d2u dx2 is 0, that means u equals to some ax plus b. That's a straight line. This is almost a straight line. If you run it much more longer time, let's say this is equals to 3, then I think this is almost straight line. Okay, and you can plot many intermediate points here, and if you just copy this part of the code many times, okay, if this is 0, this is your 1/8 time instant, 1 means 0.2, and then this is your 2, this is your 2, 0 1 2 3, sorry, this is your 3, 0 1 2 3, and the last one is many conditions are there. It is a very simple way of writing the diffusion equation. There are many more complicated ways or much more generalized ways of doing this. 0 1 2 3 4. This is the actual curve. This is the end line. This is the 3 time. This is this time, this time, this time, this time. Okay, and just you increase the number of points, say 99, making it 99. What happens to it? Fine. That means that if you this is larger, and then you have to increase the time, say 6, make it in 6. Number of points, this is you need a larger time to make a steady state. It's a huge rod, that's huge number of discrete points. It needs a larger time to this almost, and you just check it, and this is your prototype program, how to program diffusion equation, and you can play with these things. You can make length different and all that, and you can also play with the boundary conditions. Say boundary condition, both end of this is 100 and middle points are all 0 initiated, then run it. These sort of things, the both ends are 100 and middle point and intermediate points are 0, and then making it this thing. If you take, and it is almost if you run for much larger time, say 20, and then will be lifted up. I hope so. This is lifted up. This sort of thing will happen. And you can also play with the boundary conditions. Say intermediate points, say initialized with 0, and both end is say both end is 0. I can play with another thing also. Both end is 0 and initialized with say 0, and particularly the central point, not initial point, all are 0. And I also initialized with the central point, that means the n by 2 points, n divided by 2 points. The central point is say 100. Both end is 0, all the values are 0, only the central point is 100. Say that is n by 2 point, that means that there is a rod, the central point is heated, say 100 degree, and then release it. Okay, there is some error is there. That means okay, this is not a floating point kind of thing, so therefore int of that, it's an integer. It always take an integer. Division may leads to non-integral values. Yes, fine. This is the initially, that means almost equals to this a Dirac delta kind of thing. Then if you allow time, then that means it's a Gaussian curve. It's a very beautiful then the Gaussian diffusion that you know, if you just hit the central point, then you release it, then there will be Gaussian nature will be there. This is a Gaussian kind of diffusion that will be is best simulated by this kind of graph. And I am ending here. I'm just stop here. This is the whole thing, and you can make it much more complex kind of thing.